Hey guys, welcome to this session. Our topic is we're discussing about the soil properties. We've already discussed the physical properties of soil, and in the past video we started seeing the chemical properties of soil. So the chemical properties of soil, we said they include as follows. The first one is the cation exchange capacity. We've already discussed that. Then today we'll move on to soil reaction. Now let's see the soil reaction, also known as soil pH. Now soil reaction or soil pH is the measure of hydrogen ion concentration in soil solution. So it's basically the measure of amount of hydrogen ion that occupy or are concentrated in the soil solution. It can be an indication of the acidity or alkalinity of the soil. The pH scale basically it ranges from 0 to 14, with the values below 7 described as the acidic and the values above 7 described as the alkaline. A pH value of 7 is considered the neutral point, where the hydrogen and the hydroxide are equal, both at a concentration of 10 minus 7 moles per liter. So this is simple introduction to soil reaction or soil pH. Now, the most important effect of this soil pH in the soil is on the ion solubility, which in turn affects the microbiome and the plant growth. A pH range, take an example for 6 to 6.8 is ideal for most crops, because at this pH there is optimum solubility of the most important plant nutrients. Now, some micro elements, take an example, iron and most heavy metals are more soluble at a low pH, which makes the pH management important in the controlling movement of the heavy metals and the potential groundwater contamination in the soil. In the acidic soils, the hydrogen ions and the aluminum are the dominant exchangeable cations. The latter is the soluble under acidic condition, and its reactivity with water, the hydrolysis, then produces hydrogen ions. The calcium and the magnesium are basic cations. As the amounts increase, the relative amount of acidic cations will also increase. Now let's see the various factors that can affect this soil pH. Before I just few the factors that can affect the soil pH, they include as follows. The first one is the parent material. Some rocks and the sediments produce soils that are more acidic than others. Take an example, the quartz-rich sandstone is acidic while limestone is alkaline. The second factor is the vegetation. Some types of vegetation, particularly the conifers, produce organic acids which are contributing to the lower soil pH values. The third one is the climate. In humid areas, soils tend to become more acidic over time, because the rainfall washes away the basic cations and replaces them with the hydrogen ions. And now the other factors, such as the addition of certain fertilizers to soil, can also produce hydrogen ions. Also, the liming the soil adds calcium, which replaces exchangeable and the solution hydrogen ions and raises soil pH. Also, lime requirement, or the amount of liming material needed to raise the soil pH to a certain level, increases with this is CEC, that is the cation exchange capacity. Now, to decrease the soil pH, sulfur can be added, which produces sulfuric acid. So these are just few of the factors. Now let's see the effects of soil pH on the plant growth. Soil pH affects plant growth in the following ways. The first one is that it affects the availability of plant nutrients. In general, the optimal pH is between 5.5 and 7.5. So the soil pH will affect the availability. It means the presence of these plant nutrients needed for the plant growth. The second point is the low pH soils, meaning less than 6, results in an increase in aluminum ions in the soil, whereby this aluminum is toxic to plants. The third one is that it affects the availability of toxic metals in general, more available in acidic soils, and the other, it affects the activity of soil microorganisms, thus affecting the nutrient cycling and the disease risk. So in such, it affects the plant growth. So I hope it's clear, guys. Thank you for listening. We've seen the soil reaction or soil pH. We've discussed its concept. We've seen various factors that can affect the soil pH, and we've later on seen the effect of this soil pH on the plant growth. Thank you.